So the chapter for today is language of chemistry. Language of chemistry. Okay. So now we need to understand some basic terminologies or basic concepts that is applicable almost entirely in chemistry. सब topic में use होने. So we need to learn about some basic things that becomes very helpful when you study chemistry. Okay. So for me, I don't know if whether it's there in the book or not, this part. So for me, the most important term in chemistry is valency, and this is the most wrongly studied word as well. So every student, if I ask the definition of valency, every second student will have a wrong definition of valency, which actually is taught in school. Okay, and it cannot be like it doesn't go out of your head. It cannot be erased because your teacher like tells exactly the same thing. So it becomes very difficult to re-understand something that you have understood already, and if you have understood it the wrong way, and to re-understand that thing in a different way becomes difficult. So I'll tell you a definition of valency that will stand forever from today. So valency is nothing but is the number of electrons an atom loses or gains. Okay, so valency is the number of electrons an atom loses or gains. So if electron is lost, okay, if something loses electrons, then that kind of element, that kind of atom will be a positive atom after losing electron. And if something gains electron, right, if someone gains electron, then that kind of atom will be a negative atom after gaining, right? So now how do I explain this? Now for this we need to understand what is an electron, what is an atom, and what is loss or gain. Okay, now first, to understand electron, we need to understand an atom. So what is an atom? So atom is the building block of every matter. So every matter is made up of atoms. So atom is the smallest entity, right? That is the building block of a matter. There can be smaller entities, more smaller entities than atoms. Those are called electrons, protons, and neutrons. But atoms are the one that takes part in a chemical reaction. So you can like, what is H? You know which element is represented by H?
Hydrogen.
Yes, hydrogen. So this H represents an atom of hydrogen, right? If I say O, this represents an atom of oxygen, right? If I say N, if I say this means an atom of nitrogen, right? So this is how you represent atom. But what is an atom made up of? How does an atom look? What does it look like, right? So let's study about that thing now. What does an atom look like, and where do we find atoms? So the most accepted theory about atomic structure is, so we have a central mass, and this central mass is known as the nucleus. Okay, there is a central object called nucleus, and there are orbits like the solar system, like the planets around the sun. There are orbits like this, and in these orbits there are electrons revolving. Like the planets revolving around the sun, there are electrons revolving. But the only difference between the analogy between the solar system and the atomic structure is, in solar system, in one of the orbit we only have one planet, right? So there is no other planet revolving around the sun in the orbit of Earth. So in the orbit of Earth, only Earth is revolving around the sun, right? So there is no other planet with Earth that is revolving in the same orbit. There are planets that revolve in bigger orbits like Mars, Jupiter, Saturn, and there are planets that revolve in smaller orbits compared to Earth, that is in Mercury and Venus, right? But in atoms, that is not the case. There may be two or more than two electrons. Even only one electron also is possible, but there can be more than two electrons in one stationary orbit. There can be, okay? It is not a hard and fast rule that there has to be, right? But there is a certain condition that defines how many electrons are revolving around the nucleus in a particular orbit, right? But for the solar system, we know that every planet revolves around the sun in a stationary fixed orbit, and no other planet revolves around that orbit. So other planets revolve around orbits that are smaller or greater than the orbit of the planet under consideration. Like in my case, I considered Earth, right? So basically, an atom consists of a nucleus, right? A nucleus and the electrons revolving. So nucleus is basically composed of neutrons and protons. Okay, so we have three subatomic particles. So these particles are known as electrons. Electrons, protons, and neutrons together make up the subatomic particle. Subatomic particles. So we know what is atomic, right? So atomic is the atom. What is sub like a subsidiary, something that is smaller, that makes an atom work. So that makes an atom. So like for example, if you have your body, human body. So what are the things that make up a human body? What are the subhuman parts, sub-body parts? So sub-body parts are limbs, hands, legs, right? Heart, lungs, all those things. So for an atom as well, so atom, subatomic particles are basically the particles that make up an atom. So what are the particles that make up an atom? These are electrons, neutrons, and protons. So electrons are the ones that are negatively charged. They have a negative charge in them, right? Protons are the ones that have a positive charge in them, right? And neutrons do not have any charge, do not have a charge, right? So they do not have any charge. So anything that is negative, so if I like, this is actually a very high standard thing, right? I teach this the same thing to class 12 and 10 as well, but it becomes very helpful if you learn it in class 9 itself. So if I say anything is negative, okay, if I say if something is negative, which basically automatically would mean that it has more electrons, okay. If I say something is positive, then in this case it is not more protons, it is less electrons, okay. So this is a new definition for you, I think. So I'll say it again, I'll repeat it again. So if something is negative, some body is negative, or anything is negative, which means it has excess of electrons, it has more electrons in it. And if something is positive, it is deficiency or less electron. There's the quantity of electron is very low. That's why it is positive. Why is this? Because why doesn't positive means more proton? This basically is due to the fact that protons are not allowed to move inside the nucleus. So protons are very strongly held in the nucleus, okay. Protons cannot escape the nucleus. Proton, once inside the nucleus, will stay inside the nucleus unless some extremely high energy is supplied, and that is very like a completely different unit in chemistry and physics, okay. So protons, you should understand that protons are not allowed to move out of the nucleus. They are bound to the nucleus. They will not move outside the nucleus. Protons and neutrons are completely bound to the nucleus of an atom. So the only moving entity inside the atom is electrons. So the positive and negative of an atom or a material can be positive or negative only by the virtue of the motion of electrons and not by motion of neutrons and protons, because neutrons and protons are practically not allowed to move. They are completely held together by some forces, and they are completely held and they are not allowed to move. So the positive and negative that you hear, if something is positive, something is negative, that is solely due to the motion of electrons. So because electrons are free and they are allowed to move from one atom to another, they can escape an atom, they can come inside an atom. So that movement of electron defines whether a thing is negative or positive, right? So till now we studied about atoms, then we did the subatomic particles. Subatomic particles are electrons, protons, and neutrons. We got to know that protons and neutrons are located at the center of the atom, and that part is known as the nucleus of an atom, right? And everything inside the nucleus is not allowed to move. It is completely fixed, completely stationary. Nothing is allowed to come out of the nucleus. Nothing is allowed to go inside the nucleus, okay? Then electrons revolve around the nucleus like the planets do around the sun, but the only difference being that more than 2 electrons or 2 or more electrons can be in a single orbit. So more than 2 electrons can actually stay in an orbit. It is not necessary that only 1 electron has to revolve around the nucleus in one orbit, okay. So till now, if you have any doubts, just let me know right away. So if you have any questions, any doubt, let me know right away. So this is the basic about an atom. So what is an atom? How does it look like? And what is the interaction? What is the main form of interaction in the atom? So we know now the main form of interaction will be electron, because the protons and neutrons cannot be touched inside the nucleus. So if you supply energy to an atom, the only thing that can interact with the energy will be the electrons, because electrons can be pushed out of an atom or electrons can be pulled into the atom. Now, further, if we use this knowledge that we just studied right now to define valency, because our main objective was to understand valency. So now the valency is the total number of electrons that escape or come in into the atom, right? But now this thing will depend on what type of atom you are, right? So if you are a metal, let's say if you are a metal like sodium, or if you are a non-metal like fluorine, okay? So according to the periodic table, what is the atomic number of yes, yes, bye.
Okay, function.
के सुन्दैछ हैन? अब सुन्दैछ?
हजुर.
Okay. So now we need to understand what is valency now, right? Valency, I termed valency as something like, valency is the number of electrons an atom loses or gains, right? But this loss and gain of electron depends on the type of atom, what type of atom you are considering, right? So now let's say if I consider a metal like this, metal. So a metal, sodium has an atomic number of 11, let's say, and there is a thing called electronic okay. So the valency definition states that it is the number of electrons an atom loses or gains, right? But this loss and gain will depend on what type of atom you are considering, right? Right, for example, if I consider sodium is a metal, right? Sodium is a metal, and let's say it's the atomic number is 11. I'm not sure, it might be 11. Let's say it's 11. So now the electronic configuration will look something like 2, 8, 1. So this is a method. I'll explain you how we do this. This is in the second part of this chapter. So this is how you categorize electrons in which orbit. So this is the first orbit outside the nucleus. So I told you, right, nucleus is there and we have electrons around circular orbits, right? So this 2 represents 2 electrons in the first orbit. This 8 represents 8 electrons in the second orbit. And this 1 electron, because we just have 11 electrons, right? Atomic number 11 means we have 11 electrons. So 8, 9, 10, 11. So 11 is complete. So now this sodium losing and gaining electron will depend upon some factor. And this fluorine is a non-metal, and this non-metal losing or gaining an electron will depend on the same factor. So the factor is noble gas configuration. Noble gas config. So I'll import a photo of periodic table from Google and I'll explain you, okay? Wait. Periodic table. Hello? 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 Hi, can you hear me? तिम्रो इन्टरनेट प्रब्लम हो कि मेरो?
फेरि जाँदै आउँदैछ.
तिम्रो इन्टरनेट प्रब्लम हो कि मेरो?
छैन मलाई.
Download image. How do you download image? Save image as. Periodic table, periodic. I'm importing this thing. Okay, so now I talked about valency, and in valency I talked about 2 elements. What are the 2 elements that I talked about? That was sodium here, which is here. Oh, you can't see the red. You can see red there. So I talked about sodium, and I talked about another element called fluorine, right? So now before explaining, I'll tell you that valency of sodium is 1 and valency of fluorine is 1, but they are completely different ones. Okay, they are this one valency 1 of sodium is completely different than valency 1 of fluorine. Now how? I'll explain you. Now the atom, are you there in the class? Hello. Okay, so now sodium has an atomic number 11, so its electronic configuration will be 281. You don't need to worry about this, how did this came, I'll explain you in the next class. 281, and fluorine is 9, so it is 2 comma 7, so 7 8 9. So the electronic configuration of sodium is 281 and electronic configuration of fluorine is 27. And you should always be aware of this group number 18. So this element, these elements in this vertical column, right? So these things are known as the noble gases. So everything in this 18 wala column are known as noble gases. Okay, these are called NOBLE, noble gases. And noble gases, why they are called noble gases? Because these are the most stable elements. Okay, they don't react with anything. They don't care about anything that's close to them. They don't care about it. They don't react with anything, right? There are elements that are highly reactive. Okay, they react with everything that is around them. Like sodium. Sodium is a highly reactive metal. Okay, if you place a piece of sodium inside water, it will start burning, right? Fluorine is also a very pungent smelling gas and it's very reactive as well, right? But these elements, helium, neon, argon, krypton, xenon, all these things are noble gases or ideal gases. Okay, they don't react with anything. They are already stable. They don't react with anything, right? Now valency is valency we are losing or gaining electrons. We are either losing or we are either gaining electrons. Now this will depend on the stability. So will losing or gaining electron take them to the nearest noble gas state? Okay, so now sodium, the closest noble gas to sodium is neon, right? Because it is 10 and it is sodium is 11. And the next closest is argon, which is 18, right? So for sodium, the closest it has is neon, that is 10, and the next closest it has is argon. So it can lose or gain electron to become either of these two. Okay, so sodium can lose or gain electron to become either of these two. Otherwise it will not lose or gain, right? Because it has to be stable. After gaining or losing, it has to be stable. The only thing that every entity in the universe wants is stability. So to gain stability, sodium has to become either neon or argon or anything else. Sodium has to be any other noble gas, helium, neon, argon, any one of these. But the closest two are neon and argon. Now, since atomic number of sodium is 11 and that of neon is 10 and that of argon is 18, so which one will be easier? So will it be easier for sodium to lose one electron and become neon, or gain 7 electrons to be argon, because it is 18, right? To change from 11 to 18, argon has to gain 7, right? It has to gain 7. Or will it be easier for sodium to lose just one electron and be neon? Exactly. So sodium covalency is 1 because it can lose one electron, right? So when something loses electron, it will be automatically positive 1. So valency of sodium is positive 1, right? Because it has a tendency to lose one electron to become the nearest noble gas state, to come in the nearest noble gas state and become stable. So since it is losing electron, I have already told you in the previous slide that losing of electron means you'll get a positive sign, which means you don't have an electron. So if you don't have an electron, it is deficiency of electron. So when electrons are not there, it will be positive automatically. So the valency of sodium is positive 1. Now how is it different from fluorine? Now fluorine is 9, right? The closest two noble gases of fluorine, I'll erase this one second. The two closest noble gas of fluorine are helium, whose atomic number is 2, and neon, whose atomic number is 10. Now, will fluorine lose 7 electron to be helium, because helium को 2 हो, उसको 9 हो, so it has to lose 7 electron to be 2, or will it just gain 1 electron to be neon?
Gain 1 electron.
Exactly, you'll gain 1 electron, so 1 extra electron will come into fluorine, so the valency of fluorine is negative 1. Okay, so these both have valency. We don't consider the positive and negative when we write the valency. Okay, this is just for explaining purposes. So we just write the valency of sodium as 1 and fluorine as also 1. but we don't write negative and positive. It should be self-explanatory, right? Fluorine will always gain electron to be neon, and sodium will always lose electron to be the state of neon. So valency is basically the number of electrons an atom can lose or gain to attain attain the nearest noble gas state. So this is a proper definition of valency. I'll write it somewhere here. Wait. The number of electrons an atom can lose or gain to attain its nearest noble gas. This is the definition of valency. The number of electrons an atom can lose or gain to attain its nearest noble gas configuration. Gas configuration is called valency. So number of electrons an atom can gain or lose to attain its nearest noble gas configuration is called valency. So to understand this definition, you should understand which one is the noble gas, right? So we know that everything in this group, helium, neon, argon, krypton, xenon, all these are noble gases, right? And every others are not noble gases. So everything else are not noble gases, okay? Only these elements are noble gases. So let's wind this up with a simple example with one more element. So let's talk about magnesium, right? So what will be the valency of magnesium? So the two nearest noble gases of magnesium is argon and neon again. So now will it lose 2 electrons, right? Lose 2 electron to be neon, or will it gain 6 electron to be argon?
Lose 2 electrons.
Obviously it will lose 2 electrons. So the valency of magnesium is 2, positive 2, because it is losing electron. But we don't need to write this positive. So valency of magnesium is 2. Now let's go for oxygen. Now the two nearest noble gas of oxygen is helium and neon. Helium and neon. Now will oxygen gain 2 electron to be neon or lose 6 electron to be helium?
Gain 2 electrons.
Yeah, it will always gain 2 electrons. So when something gains electron, it becomes minus negative. So negative 2 is the valency of oxygen. We don't write this negative. So the valency of magnesium is 2. Also the valency of oxygen is also 2. But there is a lot of difference between the 2 of magnesium and 2 of oxygen. So are you clear with the difference between the two? What is the difference between the 2 of magnesium and 2 of oxygen? Okay, so valency is this is the definition of valency. You can write it down, take a screenshot, whatever you want. This is a very important definition. So this is the final definition of valency from today. This is valid till any standard that you study chemistry, right? This is the proper and actual definition of valency. So if you have any doubt regarding this, let me know right now. If you don't have doubt, this is the end of the class for today.